Hi, hello, welcome and welcome to the First Step Academy Learn and Grow Educational Medium. In this video, we are going to see about an overview of HCF and LCM. So, this is one of the important basic topic in mathematics. So, one who prepare for the competitive examination, they should aware about this. Then it will be easy for them to answer if they ask any question onto this topic called HCF and LCM. Right? Okay, fine. So, what is HCF? The expansion of HCF is highest common factor. Right? So, highest common factor is called HCF. In other names, it can be called as GCM and GCD, where GCM, expansion of GCM is greatest common measure, where expansion of GCD is greatest common divisor. So all threes are called in different names, but it means only one, that highest common factor. Right? Fine. What do you mean by LCM? So expansion of LCM is least common multiple. So least common multiple is called LCM. Right? We are going to see about this HCF and LCM. So what is this and how do we find the HCF and LCM of the particular numbers? So before to go directly to the topic, first we should know what is factor and what is multiple. Right? If you know that clearly, then it will be easy to find out the HCF and LCM of the given numbers. So factors and multiples, right? So just assume there is a two numbers called x and y, right? So now if this x divides y exactly, means without any remainder, then this x can be called as factor of y, right? At the same time, look at here, where y can be called as multiple of x. Once again, I'm repeating. So let's take x and y are the numbers. If x divides the y exactly without any remainder, then x is called factor of y, whereas y can be called as multiple of x. Right? Let us take one example. Just assume two numbers called 5 and 20. Let me take 5 as x and 20 as y. Right? Now look at here. If I divide 20 by 5, then is it possible to divide? Yes, of course. 4 5s are 20, so that we will get remainder as 0. That we are exactly meant exactly divides. So 5 divides 20 exactly without any remainder, so that we can call 5 is one of the factor of 20. Right? That's what I mean to here. X is a factor of y. Why I mean 5 is one of the factor of 20? We know very well about 20, right? It's an even number where it has factor called 2, 4, 5 as well as 10 and 20. Right? So 5 here is one of the factor of 20 that we found out here. So whereas look at y here is 20. So how many times of x will provide y? That is 4 times of 5 is 20. We know very well. So that's what we have meant here. Y is multiple of x. So 5 multiple of 5 will provide 20, where multiple of x will provide y. That's what we are meaning as multiple. So we know now about the factor, we know about multiple, right? So just be clear on this, so that will be much easy to calculate HCF and LCM, right? Fine, we'll go to know about HCF now. So HCF called highest common factor, whereas the other name we mentioned earlier, that GCM, greatest common measure, or GCD, greatest common divisor, right? Fine. So what it means exactly? So the greatest number that divides each of the numbers exactly, means without any remainder. Look at here, it's an important one. The greatest number that divides each of the numbers exactly, right, then that the greatest number is called highest common factor. For example, simple way, we'll take 8, 16 and 24, right? There are three numbers. Just identify which the greatest number, the highest number that divides, right, all three number commonly without any remainder, means exactly, then that exactly gives the value of HCF. Term itself says, right, highest common factor. So it should be common for all three numbers. So if you look at for these three numbers, 8 is the number that divides all these three, right, commonly without any remainder, right, where this 8 is the highest common factor of these three numbers, right, highest. That's much important. Also the common number of all these three is very important, right? Now this, how do we find the highest common factor of the numbers given, right? So there are the two major methods that we are calling as factorization method and division method. Through this we can easily able to identify the highest common factor of given numbers, as well as sometimes they will give the polynomials. So we can easily find the highest common factor of the given polynomials through these methods, mostly the division method for the polynomial. Anyway, we have two major methods to find the highest common factor. That is, one is factorization method, another one is division method. Now we are going to see one by one, right? Now we are going to see about factorization method to find HCF, highest common factor of the given numbers. So we have written here a few steps that we should be remember in our mind to calculate, to find out the highest common factor, where the first one is express the given numbers as the product of prime factors, right? We know about the prime numbers and prime factors. So the number one which can be divided by itself and one is called prime numbers, right? So we should express the given numbers as the product of prime factors. This is the first step in factorization method. The second step is that write in the form of powers. So list out all the numbers and identify how many times the numbers has come and express, write those prime factors in the form of powers, right? Then the final method is the product of least powers of common prime factors. So identify the common prime factor which will be available for all the numbers, given numbers. So then the product of least power, that's much important. Look at here, the least powers provide HCF. So the product of least powers of common prime factors will provide you the HCF, right? This is the factorization method. We'll go to we will see this based on an example so that you can easily able to understand about how to find highest common factor through the method called factorization method, right? Okay, let us take three numbers called 108, 288 and 360. So let us take three numbers. Now we need to find highest common factor of these three numbers, right? So how do you find? By the method called factorization method, right? As I said that we need to express the given numbers in terms of prime factors. So how do we find the prime factors, right? So first one, right, 108. Let it be divided by the prime factor. The lowest prime factor, we know that it is 2, right? First I will divide by 2. So how much will come? So 5 2s are 10, 4 2s are 8. Again, this can be divided by 2, hence 2. Then, so 2 2s are 4, 7 2s are 14, right? So 27 is not, we could not divide by 2, hence we will go to the next prime number where 3, check out with 3, of course 27 can be divided by 3, so 3. So 9 3s are 27. Further, it can be divided by 3, hence 3 3s are 9. Further, it can be divided by 3, so 1 3 is 3, right? That's it. We should stop over here. Now look at, these are the prime factors of the number called 108, right? So now I'm going to express that 108 is in the form called 2 into 2 into 3 into 3 into 3. I expressed. The first step is over. Now the second step, right? Now look at identify the numbers. We have to write in the form of powers. We have two 2's, so 2 to the power 2 we can write into. We have 3 3's, so 3 to the power 3 we can write. Let it be, right? Fine. Next number 288. So 288. Identify first. We should process with the lowest prime factor, right? So lowest one is 2. So 2. 1 2 is 2. 4 2s are 8. 4 2s are 8. Again 2. 7 2s are 14. 2 2s are 4. Again it can be divided by 2. So 2. So 3 2s are 6 and 6 2s are 12. Again it can be divided by 2. So 1 2 is 2. 8 2s are 16. Again it can be divided by 2. So 9 2s are 8. Further this can be divided by the next prime factor called 3. So 3 3s are 9. Further it can be divided by 3. So 1 3 is 3. Now these are the prime factors of the number called 288. Now list out 288. So 2 into 2 into 2 into 2 into 2 into 3 into 3. So how many times 2 has comes now? Look at the second step I'm doing here. 1 2 3 4 5. So 2 power 5 into 3 power 2. Right? We expressed up to second step we completed here. We'll do the final step later, right? Next number is 360. So 360 will identify the prime factor. So 2. So 1 2 is 2. 8 2s are 16. 0. Where 2. 9 2s are 18. 0. Where 2. So 4 2s are 8. 5 2s are 10. Further it could not be divided by 2. Hence 3 I am going. So 15 3s are 45. Again 3. So 5 3s are 15. Again I am bringing 5 because 5 could not be divided by 3 but it can be divided by 5. Hence 5 1 5 is 5. So these are the prime factors of 360. So I am writing over here. So 360 is equal to 2 into 2 into 2 into 3 into 3 into 5. Look at here, we can express in terms of power. So 2 to the power 3 into 3 to the power 2 into 5 to the power 1. So now we completed up to 2 steps. So we identify the prime factors we identified and we have written in the form of powers. We have written for all 3 numbers. Now the final one, we should identify, we should take out the least powers of common prime factors. That's much important. Look at the least powers of common prime factor. First you identify the common prime factors. So what are the common prime factors? Look at in 108 we have 2 and 3. In 288 we have 2 and 3. But in 360 we have 2, 3 and 5. Where 2 and 3 is common in all 3 numbers. Where 5 is not common for all 3 numbers. Hence we could not consider the 5. So we should consider only 2 and 3. Right? In this 2 and 3 identify the least powers. Right? Least powers you can identify. So least power is 2. Least power 2 power 2 is least. So 2 power 2 into in 3, so look out which one is the least power. So 3 power 2 of course. So 3 power 2. So now this multiple of the least powers of common prime factor we identified here. We need to get the value. So 2 power 2 is 4 into 3 power 3 is 9 where 9 4s are 36. Where 36 is the highest common factor of the numbers given is 108, 288 and 360. Means highest common factor of the numbers 108, 288 and 360 is 36. Right? So this is the way that we can able to identify, we can easily identify the highest common factor of the given numbers through the method what we called factorization method. Right? Hope we can able to follow up. Fine, we'll go to the next method, division method. So the division method is another method, one of the important method too, where through this we can able to find the highest common factor of the numbers given, as well as if they give any polynomial, then the highest common factor of the particular polynomials also we can able to identify through this method, right? Fine. What are the steps that we should follow here in the sense to find the HCF? First one, divide the larger number by the smaller one. If they give 2 or more than 2 numbers, so first we need to divide we should identify the larger number, then first we should divide that larger number by the smaller one, right? Next step, divide the divisor by the remainder. Further we should follow whatever the remainder we get, right? So that remainder we should take it as a divisor, so that the divisor will become dividend. So we need to divide the divisor by the remainder, right? Next step, repeat till the remainder is 0. This process we should continue till the remainder is 0, right? Then the last divisor what we get, when we get the remainder is 0, at the time which one is the divisor, that we should identify. That divisor exactly gives the value of highest common factor, right? This is the method. Anyway, we'll see one example so that you can easily able to grasp how to find the method, grasp the steps, how to find the HCF through the method called division method. Okay, let us take 3 numbers to find the highest common factor by the method called division method, right? So those 3 numbers are 2, 4, 3, 5, 1, 3 and 1, 1, 3, 4, means 243, 513 and 1134. Now we are going to find the highest common factor of these 3 numbers by the method called division method, right? First step, what is the first step? Divide the larger number by the smaller one. Just identify which one is smaller. So this is the larger number, where this is the smaller number, where this is the smallest number among all these 3, right? So we identified the larger number as 1134. So 1134, let it be 1134, right? Now the smaller number is 513. So we need to divide this number by the smaller one called 513. This is the first step. So we'll divide now, right? So how many 513 will come? 2, right? 2 we can put here. So 2 3s are 6, where 2 1 is 2, 5 2s are 10. So remainder is, so 14 means 8. So 0, where 108 is the remainder, right? Fine, we divide it. Next step, divide the divisor by the remainder. Look at here, the divisor is 513, where the remainder is 108. So we need to divide the divisor by the remainder. Now what will happen in the sense, it will be like this, where this divisor will become dividend, where the remainder will become divisor. We need to do this, right? This is the second step. So how do we divide now? So how many? So 4 times we can put, so 4. So 8 4s are 32, remaining 3. So 3. So 1 4 is 4. So if I subtract, so what the value will get? 3 minus 2 is 1. So 11 minus 3 is 8. 81 we get. Now we need to repeat, because we got some remainder. Until the remainder 0, we should repeat this process. Now what will be happen? Look at here. This remainder will become divisor, where the divisor 108 will become dividend, right? So 108. So now what the number will come? So 181 is 81, right? Just subtract now. What will get? 8 minus 1 is 7. 10 minus 8 is 2. Now look at, so this again we got remainder. Now again we have to repeat the step. So this will become divisor. 81 will become what? 81 will become dividend. Now divide it. How many 27 is 81? 327 is 81. So now we got remainder as 0, right? Now we got remainder as 0, where the divisor is 27. So we should identify the divisor now. So the divisor is 27 at this moment. Hence 27 is highest common factor of the 2 numbers called 513 and 1134. Now we found the highest common factor of these 2 numbers, right? How do you find the highest common factor of 2, 4, 3 also, right? Now what we need to do, this is the highest common factor, right? Now the 243 should divide by the highest common factor, right? Now the steps will follow. Now I will take 243 as the dividend, 27 as a divisor. Now divide it. How many 27 is 243? Yeah, of course, 9 27 is 243. Am I right? So 9 7s are 63, remaining C. 2 9s are 18 plus 6 is 24. So it will become 0. Now we got remainder as 0. Look at the divisor. The divisor is 27. So again, the highest common factor of 243, 513, 1134 is 27. Right? We identified the answer is 27. This is the way that we should calculate, we should find the highest common factor of the given numbers by the method called division method. So what are the steps? Once again, I'm repeating the steps. Look at, so we have to identify the larger number of the given numbers. So we need to divide the larger number by the smaller one, right? So we have taken like this. So when we divide, we'll get remainder, right? So now the remainder will become divisor and the divisor will become dividend, so that we have to divide until we'll get remainder is 0. So at this moment we should look out the divisor. What is the divisor? So the divisor exactly gives you the highest common factor of the particular number, right? For the third number, what we need to do in the sense, the smallest number is there, no, that we should take and we should divide that number to the common number what we identified here. So when we divide it, so until the same step we should repeat until we get 0, we should divide. At the moment we should look out the divisor. That divisor exactly means the common highest common factor value, right? So the highest common factor we identified by the division method. What we identified for the given number 243, 513 and 1134 is 27. Now we'll go to the least common multiple. Hope you understand. So for the highest common factor, we'll go to the least common multiple, right? Fine. Now LCM, right? Least common multiple, right? So what do you mean by least common multiple? The least number which exactly divisible by each one of the given numbers is called least common multiple. So the least number, the smallest number which exactly divisible by all of the given numbers, right, without any remainder. That's what exactly we mean over here. So that the number is called least common multiple. For example, if you take 2, 4 and 6, if you want to find out what is the LCM of these numbers, what is the least common multiple of this number, in the sense the value is 12, right? Value is 12. So how you say 12 in the sense, 12 is the smallest number, the least number, where it can be divided all these three numbers without any remainder. We know that 12 by 2 it will provide 6, where 12 by 4 it will provide 3, where 12 by 6 it will provide 2. So we will not get any remainder, right? So if we take less than this 12, any number, definitely we could not divide all these three numbers without any remainder. If we take 10, of course 2 only we can able to divide. If we take 8, we can able to divide only 2 and 4. If we take 6, we can able to divide only 2 and 6. We could not able to divide 4. Hence, in this point of view, if you take 12 is the number where that is the least number, that is the smallest number that can be able to divide all these three numbers. Hence, that is we are calling as least common multiple of the given numbers, right? Hope you can able to understand what is that. Anyway, we are going to find the LCM of the given numbers by two major methods. When we go to the topic, then you can able to understand much easily. You can able to understand more, right? Fine. So we have two major methods to find this LCM as like in HCF. One is called factorization method. Another one is called common division method. So one is factorization method, another one is common division method. Now we are going to see one by one. Let's go to the first topic, first type called factorization method. Fine. Factorization method is one of the method to find LCM of the given numbers, where we are here also we have written in the form of steps, right? We should follow these steps to find out the LCM as like in the HCF. So HCF also we have the method called factorization method, the same way, but at the end there is a twist. Let's see one by one, right? The first step to find LCM of the factorization method is express the given numbers as in the product of prime numbers, right? So we should identify the prime factor of the given numbers, right? We should express it. Second step, write in the form of powers, as like in HCF, right? Write in the form of powers. Fine. The third step is much important. Look at here. LCM can be identified as by the product of highest powers of all the factors. Product of highest powers of all factors. That's much important, right? So where in HCF we have seen about the least powers, but here we are focusing on the highest power of all the factors of the given numbers, where there we have seen about the common factors, right? So hope you can able to follow the steps. First step is express the given number as a product of prime factors. The second one, write in the form of powers. And third one, the product of the highest powers of all factors will provide you the LCM of the given numbers. Fine, we'll go to the example. With the example, you can able to we can easily able to understand how to find, right? Okay, let us take three numbers. One is called 72, 108 and 2100, right? Let us take three numbers, 72, 108 and 2100. So now we need to find LCM, least common multiple of these three numbers, by the method called factorization method, right? So how do we do? As like, first we should identify the prime factors. So 72, first I have taken. So first we'll divide by lowest prime factor called 2. So 3 2s are 6, 6 2s are 12. Again it can be divided by 12. So 1 2 is 2, 8 2s are 16. Again it can be divided by 12. And 9 2s are 18. Again it can be divided by 3. Could not be divided by 2. So we should divide by next prime factor called 3. So 3 3s are 9. Again 3, 1 3 is 3. So these are the prime factors of the number called 72. So 72. So prime factors are 2 into 2 into 2 into 3 into 3. This is the first step. We have expressed, okay, as the product of prime factors. The second step, we should write is in the form of powers, right? So 2, 1, 2, 3. 3's are there. So 2 power 3 into 3 power 1, 2. So 3 power 2. Second step over. We'll do the final step later. So next number 108. So we need to identify the prime factor of 108. This is 2. 5 2s are 10. 4 2s are 8. Next, it can be divided by 2. So 2 2s are 4. 7 2s are 14. Next, it can be divided by 3. Hence 9 3s are 27. Next, it can be divided by 3. So 3 3s are 9. So next, it can be divided by 3. So 1 3 is 3. So these are the prime factors of 108. So I'm going to express. So 2 into 2 into 3 into 3 into 3. Express in terms of powers. So 2 power 2 into 3 power 3. Okay, next we'll go to 2100. We'll find the prime factors. So first will be divided by 2. So 1 2 is 2. So 1 could not be divided. So 0. So 5 2s are 10. So 0. Right. Next it can be divided by 2. So 5 2s are 10. Then 5 2s are 10. Then 2 2s are 4. Then 5 2s are 10. Now look at, it can be divided by 5, hence I have chosen 5 as a factor here. So 1 5 is 5, so 2 could not be divided, so 0, so 5 5s are 25. Again it can be divided by 5, so 2 5s are 10, so 1 5 is 5. Now look at, it is 21. Check out with the lowest prime factor, where 3 it can be divided by 3, hence 3. So 7 3s are 21. So 7. So we could not divide by 2 or 3 or 5. So we have to choose the next prime factor called 7 itself. So 1 7 is 7. So these are the prime factors of the number called 2100. Now I am going to express that in terms of prime factors. So 2 into 2 into 5 into 5 into 3 into 7, where 2 power 2, where 5 power 2, where 3 power 1 into 7 power 1. So these are the prime factors that we have expressed in the form of powers. Now the third step, very important step. So identify the highest powers of all factor. So don't look out the common factors. So we have to choose all the factors that to the highest powers of the all factor, right? So highest powers of all factor, look at, so 2 is there, where 2 power 3 is the highest, where, so 2 power 3 I have selected, where the other factor 3, look at 3 power 1, 3 power 3, 3 power 2, so 3 power 3 is the highest power, so I have chosen. Where look at the 5, so we have 5 power 2 is there, so 5 power 2 into, look out 7, so 7 power 1 is there. This is what exactly I mean. The third step much important. Here we should not look out only the common factor, where we have to choose all the factors available for all the numbers, for each numbers, right? So where we have to pick the highest powers, where the highest powers in 2 is 2 power 3, where the highest power in 3 is 3 power 3, where highest power in 5 is 2, so we have chosen 5 power 2, where highest power in 7 is 1, so we have chosen 7 power 1. Now multiple all these three numbers, right? 2 power 3. So 2 power 3 is how much will come? So 2 into 2 into 2. Where 3 power 3 is 3 into 3 into 3. Where 5 power 2 is 5 into 5. Where 7 power 1 is 7. Now multiple all these numbers. So 2 2s are 4, 4 2s are 8. So 8 into 3 3s are 9, 9 3s are 27. 5 5s are 25 and 7, right? So when I multiply this number, I get the value as 37,800, right? I get the answer as 37,800, where this 37,800 is LCM, called least common multiple of all these three numbers, right? So it means that this is the number where 37,800 is the number that can be divisible by all these three numbers commonly, right? So we found now the LCM of the given numbers called 72, 108 and 2100 by the method called factorization method, where once I am repeating the steps, first we should express the given numbers in terms of prime factors, and we should write in the form of powers, right? We have written for all these three. Then we should identify the highest powers of all factors and we should multiply that, so that we'll be able to get LCM of the given numbers. Fine. Hope you can able to understand, hope you can able to follow up. Fine. Let's go to the next method called common division method, right? So the next method is common division method to find LCM, called least common multiple. We have a certain steps, so if you remember the steps, it will be easy to find LCM of the given numbers by this method, through this method, right? Fine. The first one, arrange the given numbers in any order in a row. So if they give any more than two numbers, then we should arrange in any order. It's not mandatory that ascending order or descending order. We should arrange the given numbers in any order in a row. That's the first step, right? The next step, divide by a number which divides exactly two of the given numbers, right? At least two of the given numbers. That's much important. So divide by a number which divides exactly two of any given numbers, at least two numbers. So we should divide those numbers by a number that mostly a prime number. So okay, by the number that should divide at least two numbers of the given numbers, right? So third step is repeat the process till no two of the numbers are divisible by the same number except one. So that we should continue until we'll get no two of the numbers are divisible by the same number except one. That's a third step. Anyway, we'll see example so that we can able to understand much clear about the steps and all, right? Just look out the theory first. Next, how do you find the LCM? In the sense, LCM of can be find the product of the divisors and undivided numbers will provide LCM. So LCM of the particular numbers, further how do we find? In the sense, the product of the divisors, so far what we get, and undivided numbers will provide you the LCM of the given numbers. So what are the steps? We have four major steps. First one is called arrange the numbers, given numbers in any order in a row. The second number we should divide by any number, mostly the prime factors, right? So which divides exactly at least two of the numbers, two of the given numbers. Then repeat the steps until no two of the numbers are divisible by the same number except one. Finally, LCM can be able to get by the product of the divisors and undivided numbers. These are the steps. Just keep in your mind. We'll go for an example so that you can able to understand much easily, right? Fine. We'll go to the example now. Okay, let us take four numbers called 16, 24, 36 and 54, right? So we should find LCM of these numbers by the method called common division method, right? The first step, as I said, we should arrange this number in any order. Doesn't matter, it should be in ascending or descending order. So as like I have taken 16, 24, 36 and 54 in a row. We have arranged now. Now second step, we should divide a number by a number, okay, by a number that should divide at least two of the given numbers. There are four numbers, at least two of the numbers should divide by the number. By the way, we should choose the division, right? First, look at all are even number, hence I am choosing 2, right? So now 8 2s are 16 and 12 2s are 24 and 18 2s are 36 and 27 2s are 54. Let it be. Next, look at here. So we have 3 even numbers, hence again I can go for 2. So 4 2s are 8, 6 2s are 12 and then 9 2s are 18 and then 27 I can, because 27 could not be able to divide by 2, hence I can keep it as 27 itself. Next, I can go for 2 again. So 2 2s are 4, 3 2s are 6, 9 could not be divided by 2, so 9 let it be, because we can divide but remainder will come, so the remainder should not come, so I can keep it as it 9. So 27 I will keep it as it 27. Next, it can be divided by 2 again. So is it possible to divide by 2? No, because only 2 will divide by 2, so that we could not divide by 2 here, because at least 2 numbers should divide, hence I can go for 3, right? Because 3, 9, 27s are there, these are the multiples of 3. So let it be the 2 as is 2. So 1 3 is 3, then 3 3s are 9, then 9 3s are 27. Next, we have to go again for 3. So 2 let it be 2. So next 1 let it be 1. So 3, look at 3. So 1 3 is 3. So next 9. So 3 3s are 9. Now look at here. We got 2, 1, 1 and 3. So now I could not pick any number except 1 to divide these numbers. So I will stop with this. I will stop with this, right? So we have completed 3 steps. Now look at what are the divisors. These are the divisors. What are the remainders? These are the remainders. So multiples of these divisors and these remainders will provide you the value of LCM, right? So now we'll do. So 2 into 2 into 2 into 3 into 3, where 2 into 3 into 1 into 1. These are the values. Now multiply it. 2 2s are 4, 4 2s are 8, 8 3s are 24 into 3 2s are 6, 6 3s are 18. So 18 into 1 is 18. So 24 into 18 that we got. 24 into 18 gives the value as 432. Right? So 24 into 18 will provide the value as 432, where this 432 is LCM of the given numbers called 16, 24, 36 and 54. Right? This is the way we should find LCM of the given numbers by the method called common division method. Once again, I am repeating the step with the numbers. So arrange the given numbers in any order in a row. This is the first step. Then divide by a number which divides exactly at least 2 of the given numbers. That's much important, right? So I am divided. Continue that step, right, until we get no 2 of the numbers are divisible by the same number except 1. So we continued and we stopped over there. Now how do we find LCM? In the sense, the product of the divisor what we obtained so far and the remainder what we obtained. So the product of this divisor and remainder will provide you the LCM, the least common multiple of the given numbers. So we obtain the value 2, right? This is the method called common division method. Hope you understand how we can able to identify, how we can able to calculate the least common multiple by this method, right? Fine, good. We'll go to the next topic. The next topic that we are going to see here is the relation between the HCF and LCM, where if they give any two numbers, then the product of those two numbers is equal to the product of HCF of those two numbers and LCM of those two numbers, right? So the product of two numbers is equal to product of HCF and LCM of those two numbers, right? This is a relation which is much important. Based on this also a number of problems may ask in the competitive examinations. We'll see an example. There are the two numbers, right? So let it be a two number. HCF, highest common factor of those two numbers, they have given as 11, right? Highest common factor. Where LCM of those two numbers they have given as 693. And one of the number, we said that those two numbers, right? One of the number they have given as 77, right? One of the number they have given as 77. If they ask us to find out what is the another number, then we can easily use this relation to find out the another number, right? How do we find? As I said, the product of those two numbers. For example, if you take those two numbers as x and y, so product of those two numbers called x and y is equal to product of HCF and LCM. Now they have given one of the number as 77, that I have taken as x, right? So we need to find the other number called y here. So how do you find? In the sense, x into y is equal to HCF into LCM. This is a relation where x we know that is 77 into y, which is equal to HCF they have given as 11, where LCM they have given as 693. So through which we can easily find the other number called y. How do we look at this 77? We will go to the other side, so it will become division. Hence y is equal to 11 into 693 divided by 77, right? Through which if we solve this, we can easily able to identify the y value, where y value what we get is 99. The other number we got over here. So for these kind of problems, we can easily we can use this relation that we are calling as product of two numbers is equal to product of their HCF and their LCM. So one of the important formula that everyone should keep in your mind. Fine, we'll go to the next one. So HCF and LCM of fractions, where if they give a number of fractions and if they ask us to find out the highest common factor of those fractions or least common multiple of those fractions, then we can use these relations where HCF is equal to highest common factor of numerators divided by least common multiple of denominators. We know about the fractions, so a by b, right, is in the form, this is called, we are called as fractions, where if they give in the form a by b of more than two numbers, if they ask us to find out the HCF or LCM, then as I said, we can use this relation where we know that the a is the numerator where b is the denominator. If they have more than one a, so for example a1 by b1 comma a2 by b2, then how do you find HCF of these two numbers? In the sense, look at HCF of numerators first we need to find, right? So a1 and a2, so HCF of a1 and a2 divided by, we need to find LCM of b1 and b2. So this exactly will provide you highest common factor of the particular fractions. The same way, if you want to find out LCM, look at LCM of numerator first we should take. So LCM of a1 and a2 we should take, then HCF of denominators we should take. So that exactly will provide you LCM of the given fractions. This is the relation, important one, keep in your mind. We'll go for an example so that you can able to understand much easily, right? Okay, for example, we'll take a few fractions called 2 by 3, 8 by 9, 16 by 81, 10 by 27. Okay, let us take these fractions and we'll find out highest common factor as well as least common multiple. As we said that first, highest common factor. What is the relation? So Hcf of numerators divided by Lcm of denominators. Right? So look at, these are the numerators where 2, 8, 16, 10s are the numerators, where 3, 9, 81 and 27 are the denominators. So first we should find highest common factor for 2, 8, 16 and 10. So how do we find, right? So 2. So how do we find HCF, right? So express in terms of prime factors. So it is only 2, let it be. Next 8. So 2 can be written as 2 power 1. Where 8 can be written as 2 into 2 into 2. So 2 power 3. Where 16 is expressed as 2 into 2 into 2 into 2. Where 2 power 4. Where 10 can be expressed as 2 into 5, where it can be written as 2 power 1 and 5 power 1. Right? So look at the powers. We should identify the least powers of the common factors. The common factors are 2, where the least power is 2 power 1. Hence, HCF of numerator is 2 power 1, which is equal to 2. So HCF of numerators we found here, that is value 2. Now what we need to do? Now we need to calculate LCM of denominators. So how do you find the LCM? We know very well, denominators are 3, 9, 81 and 27. So 3 list out, because I have chosen factorization method, so it will be a bit easy, so that I have chosen here. So factorization method we are doing here. So 3, so the prime factor is 3, so we have written as 3 power 1. Where 9, it can be expressed as 3 into 3, where 3 power 2. Where 81, it can be expressed as 3 into 3 into 3 into 3, so 3 power 4. Where 27 is there, so 3 into 3 into 3, where it can be expressed as 3 power 3. So look at the highest powers, look at the common factors. Common factors are 3, where the highest power is 3 power 4. Hence this is LCM of the denominators. So 3 power 4 can be expressed as 81. So we found now HCF of numerator is 2, where LCM of denominators are 81. So the highest common factor of the given fractions is 2 by 81. This is the answer. This is a way that we can easily find the highest common factor of the fractions, given fractions. Fine. Next we'll see about least common multiple of these fractions, right? So least common multiple can be calculated by LCM of numerators divided by HCF of denominators. Right? Now look at the factors. These are the numerator, these are the denominators. So now we need to find LCM of numerator. So what is the LCM of the numerator that we'll get? Look out the highest power. So highest power is 2 power 4. So LCM of numerator can be calculated by 2 power 4 into 5 power 1 is there. So 5 power 1 divided by, where the denominator, HCF of denominators, look out the least power. Least power is 3 power 1. Hence 3 power 1 will be there. Next 2 power 4 is 16. So 16 into 5 is 80. So 16 into 5 is 80. So 80 divided by 3. So the least common multiple of the given fractions is 80 by 3. We know very well LCM. How do we take LCM and how can we calculate the HCF? So through which we calculated these values and we found LCM of the fractions as 80 by 3. Hope you understand. So for what we discussed in this topic called highest common factor and least common multiple. So once again I will rewind quickly. So what we have seen. So we have seen about multiples and factors, and we have seen about what is HCF and how do we find those HCF by the methods called factorization method and division method. Then we have seen about LCM, called least common multiple, where that is also having two major methods to find the LCM of the given numbers, where those methods are again the factorization method and common division methods. Then we have seen about the relationship between HCF and LCM. Finally, we have seen about the relations to find highest common factor and lowest common multiples of fractions, right, with an examples. Hope it will be much useful to you. If it is really useful to you, kindly subscribe to our channel, like our video, share to your friends. Thank you once again. This is your The First Step Academy, Learn and Grow Educational Medium.